All right, this is going to be the video to go through the problems on formative number 2 about the remainder and factor theorem. All right, so jumping right into problem number 1. A function and one of its factors is given. Use division long or synthetic to find the other factor. My personal preference, if I have the option, is to use synthetic division. However, because this factor has a coefficient other than 1 for x, I am going to actually choose to do long division. Now, if you choose to do synthetic, that is totally fine. You would have different work, but your answer at the end would be the same. So long division, we're going to take 21x squared divided by 3x. Well, that's going to be 7x. 7x times 3x is 21x squared. 7x times 2 is going to be plus 14x. I'm going to zoom in just a little bit. I need to take these two terms and I'm going to subtract them. So the first two terms cancel as they should. And then I'm going to do 5x minus 14x, so negative 9x. Drop down that 6. Start again. Negative 9x divided by 3x is going to be negative 3. Negative 3 times 3x, negative 9x. Negative 3 times 2 is negative 6. And I want to subtract those. Negative 9 minus negative 9x minus negative 9x will cancel. And negative 6 minus negative 6 will cancel. And we have a remainder of 0, which is as it should be. If you got a remainder other than 0, something went wrong with your division. Because we knew this was a factor, we have to get a remainder of 0. So what is the other factor? 7x minus 3. So whether you do long division or synthetic division, that would be your answer for problem number 1. All right, problem number 2. Use the factor theorem to determine the unknown coefficient a given x minus 2 is a factor. Now, you can do this problem one of two ways. I'm going to show you both. So I'm literally going to split this problem down the middle. And in the first case, I'm going to use synthetic division. Okay. So for synthetic division, we know we've got a 0 at, or a factor of x minus 2. So if I do that equal to 0, I know x is 2. So I'm going to set up my synthetic division using 2 and the coefficients from this f of x term. So be careful with your coefficients. We've got 2, let's see, negative 1, negative a, and 10. So 3, 2, 1, 0. Yep, okay. First number drops. 1 times 2 is... Whoops, I don't know why I just wrote 2. Doing the math in my head wrong. All right, it's 2 times 2, which is 4. Negative 1 plus 4 is 3. 2 times 3 is 6. Now be careful when you add this up. Negative a plus 6, sorry about that, is just negative a plus 6. It becomes two separate terms just held together with addition. Now I'm going to take each of those terms... I'm going to zoom in so I have a little bit more space here. I'm going to take each of those terms and multiply it times 2. So negative 2a plus 12. Now I want to use these and add them up vertically. So negative 2a plus 22. Now, in order for x minus 2 to be a factor, this remainder has to be 0. So negative 2a plus 22 equals 0 and solve for a. So I'm going to subtract 22 from both sides and divide, and I'm going to get a is equal to 11. So that's the coefficient for this problem for our a value. But I said there was two ways to do this. Synthetic is just one way. The other way is using your function value. Okay. So for the function value, we're going to start with the same thing. We're going to take that factor of x minus 2, set it equal to 0. X is 2. And what we want to do is figure out f of 2. So every place I have an x, I'm going to replace it with a 2. Be careful with the a term. okay? And as I said in the synthetic division problem, our remainder is supposed to be 0. Well, in the function value, the remainder is equal to the function value. So if this is supposed to be 0, we can say 0 is equal to, and then figure out some of these pieces. 2 cubed is 8. 8 times 2 is 16. Minus 2 squared is 4, so minus 4. I'm going to rewrite this in an order I prefer with the number first. So negative 2a plus 10. I'm just going to leave as plus 10. I'm going to combine up a few like terms here. So 16 minus 4 is 12. 12 plus 10 is 22. So 22 minus 2a. Solve for a. I'm going to subtract 22 from both sides. So negative 22 equals negative 2a, divide by negative 2, and a is equal to 11, which is not shocking at all because these two methods, while completely different, should still get you the same answer, and they do. So whether you do problem number 2 with synthetic division or the function value, it just depends on what makes sense, but please be careful when you do it that you know where all the pieces go. All right, problem number 3. Is x plus 1 a factor of the function? Well, we've just been talking about doing factor theorem. And so factor theorem says if I do synthetic division or any division and the remainder is 0, then what I was dividing by is a factor. So I have a tendency to like synthetic division if it's pretty simplistic to work with, and x equals negative 1 is pretty simplistic to work with. So I'm going to use negative 1 here, coefficients only, so negative 2, negative 1, 7, and negative 4. A little bit of workspace there. Drop that first value. Multiply. So that's negative 2, add them up. Negative 3, multiply. Let's see, that's going to be 10, negative 10, negative 14. All right, my remainder here is negative 14. That means that x plus 1 is not a factor because the remainder, whoops, helps if I spell remainder right, remainder is not 0. It doesn't matter what the remainder is. If it's anything other than 0, it is not, whatever you were dividing by is not a factor. All right, so that's number 3. Sliding on down to number 4, we want to, it specifically says we have to use synthetic division to determine f of 5. So we already know that x is equal to 5. That's what the function value here is. I'm going to grab the coefficients of this problem. So 4, negative 19, negative 4, negative 3, and negative 7. I don't believe I need any placeholders. 4, 3, 2, 1, none. I do not need any placeholders. All right, first term drops, multiply, add them up vertically, multiply, add them up vertically, multiply, add them up vertically, multiply. And the last part here is to add, so we're going to get 3. Now, what you need to remember is when we're talking about finding these function values, the only value that matters in this entire problem, now that we've got the solution, is the remainder. So our function value, when x is equal to 5, is the value of 3. All right, whatever this remainder is, that's it. All right, last problem here. Problem number 5, we are given a graph. We have the equation of g of x here as well. And we are asked to find all of the zeros of the function. Now, what you want to do is start by looking for the ones that are obvious. And so when you look at this, the graph crosses here very obviously at, what is this? X is equal to negative 2. So that's one of our zeros. We have a value here where x perfectly crosses through, so that's going to be x is equal to 1. And we have this value between 3 and 4. Now, unfortunately, you don't get to guess, right? That's not how this problem works. Oh, it's between 3 and 4. It's got to be 3.5. No. So what you want to do is use either of these to start with, and you're going to start basically dividing these answers out of this polynomial. And I would highly recommend doing synthetic division for this, and I'm going to show you how to do basically stacked synthetic division. So the first thing we're going to do, I'll go ahead and use the -2 to start with. It won't really matter. And I'm going to grab the coefficients here from this first problem. So we've got 3, -7, -16, and 20. Let me move over a little bit. All right, so drop the first term. So let's see, that's going to be -6. Add them up vertically. That's going to be -13. Multiply is going to be 26. Add is going to be +10. Multiply is -20. My remainder is 0. Now, that has to happen because we know that x equals -2 is one of our x-intercepts, which means that x plus 2 would be a factor. So yeah, that has to be a remainder of 0 here. Now, that was one of our values that we knew from the graph. We're going to use the other value and divide it out of this piece that's left over. So I'm just going to let my synthetic division keep going here, but this time I'm going to use x is equal to 1. A little bit of workspace, and I don't need to worry about this 0 at all because that 0 has been, it was the remainder. I'm not dealing with the remainder, okay? So first term drops, there's going to be a 3. 1 times 3 is 3. Add them up vertically, we get -10. 1 times -10 is -10. Add them up vertically, we get another remainder of 0, which is as it should be, all right? Again, if you're not getting these zeros, something is going wrong, okay? So just be aware of that. So this is my remainder. And if you don't need to write this little note to yourself, don't. Here's my constant. And then this is my x term. So that means my last factor here is going to be 3x minus 10. All right. Now, this particular problem said to determine all of the zeros of the function. So to find my 0, I'm going to take that factor, set it equal to 0, and solve for x. So 3x equals 10, divide by 3. X is equal to 10 over 3. And I am actually completely content with you leaving that answer in fraction form. In fact, I'd prefer it that way, unless the directions specifically say to give me a decimal. So the 3 zeros of this function are x is equal to -2, x is equal to 1, and x is equal to 10 over 3. 2 of those you knew just by looking at the picture. And honestly, 10 over 3 is, if in decimal form, it's 3.33, which makes sense if you do look at the graph. All right, but we didn't know exactly where it was just by looking at the graph. All right, I hope this has helped answer a few questions or concerns about this formative. If you've got any questions, please let me know and I will help you out.